Hey everybody, welcome to the next video of the course. This video is about randomness inside Python, in particular generating random numbers. This material is incredibly useful for any sort of game program you want to write where there's chance involved, or really any scenario you want to program where the scenario you're modeling has any sort of randomness involved. So the goal of this video is to show you how to get random numbers in Python and then integrate that topic into topics we previously covered, loops, if statements, etc. So we'll write a program that involves some like casino games. We'll integrate random numbers that way into what we have. Okay, so first and foremost, if you want to generate randomness inside of Python, the start of your program needs this line: import random. So what is that doing? That's plugging into a pre-existing library of a bunch of stuff somebody else has already built. That pre-existing library takes care of what it means to randomly generate something. So it's actually kind of a borderline philosophical question. What does it mean to say randomly generate a number between 1 and 10? And once you figured out what you mean by that, how do you get a computer to do that for you? All of that is baked into that library. We don't have to worry about it. Once we have that library, we can just generate random numbers inside of a given range using a command like this: random.randint. Int is short for integer, so we are generating random integers here, random whole numbers. And once we've generated them between A and B, we will store the result inside of number. So for example, if you write this random.randint 110, that will generate for you a randomly chosen number between 1 and 10, and it will save the result inside this variable number. Notice, by the way, this randint is inclusive on the 1 and the 10. So we've had other scenarios where you might start at 1 and end just before 10, end at 9. That's not how this is working. Okay, here you can be 1 or you could be 10 or anything in between when you do the random number generation. Okay, so keep that in mind. It's not like the range on a for loop or something, right, where you end early. Here you could actually be 10. Okay, so one obvious application of this is to roll some dice. So a standard die has 6 sides, right? So you choose at random a side, right? A number between 1 and 6. So here's how you might do that. Die 1 equals random.randint 1 to 6. Okay, so that will generate for you a random number between 1 and 6 and put it inside of die 1. If you want to roll 2 dice and record their sum, here's how you can do that. Roll the first dice, roll the second dice, right, and then record their addition. So sum here will be a number between 2 and 12, right? If both dice roll 1, sum will be 2. If both dice happen to roll 6, the sum will be 12, and it can be anything in between. Okay, so here's a more complicated example. Let's write code that simulates rolling 5 dice, stores the results in a list. Okay, so we're going to create a list of length 5, and each element of the list is a randomly chosen number between 1 and 6. So here's a way you can do that using a for loop. So dice rolls, initially we have no rolls because we haven't done anything yet. Okay, now for k in range 5, now the way this for loop is set up, just like from previous material, this k variable will start at 0 and it will go until it reaches 4. Right, so with a for loop, you end 1 early. You don't reach 5. So the values of k start at 0, then become 1, 2, 3, 4. Right, so there are 5 values k will take on. Thus, this loop will run 5 times, right? Starting when k is 0, ending when k is 4. And what happens inside the loop is you roll a dice, right? Choose a random number between 1 and 6. And then each of those rolls gets tacked onto this list. So after this loop is done running, dice rolls will have 5 randomly chosen numbers inside of it, all between 1 and 6. Let's do a more complicated example now using a casino type game. This game used to be popular, is no longer popular. If you go to the casino on the riverfront, you won't be able to play this with anybody. But you used to be able to play this game in casinos. And the reason we're doing it is because it's straightforward enough for us to write a program quickly. So here are the rules of the game. You place a bet on high or low. So basically you decide ahead of time if you think 2 dice are going to roll something high or roll something low. Okay, so you roll 2 standard 6-sided dice and record the sum. That roll is called high if the sum is at least 8. Okay, 8, 9, 10, or 11, 12. Those are the options for high. The roll is low if the sum is 6 or less. So 6, 5, 4, 3, 2. And you win the game if your bet matches the roll. So if you bet high and the roll is high, you win. If you bet low and the roll is low, you also win. So you can win 2 ways, right? Because you have 2 different bets you could make. If you bet high and the dice roll is low, you lose, right? Notice, by the way, that you can only bet on the sum being 8 or bigger or 6 or smaller. You can't bet on 7. So a roll of 7 is sort of like the house roll. The house always wins on 7, at least in this variant of the game. Okay, so there's no typo here with a 7 missing. You just can't bet on a 7 with these rules. Back in the day when people used to play this game, you know, some places would allow you to bet on 7 as its own separate category, and some wouldn't. Okay, so the variants or the rules vary based on where you would play this game. Anyway, here's a sort of a stripped down standard version you might have played at casinos back in the 1920s or whatever. So let's write a program that lets the user play this game as many times as they want. Okay, so let's see how that goes. Here's a schematic of the program. You should get the bet from the user, right? High versus low. What do you want to bet on? You should then roll the 2 dice and record the sum. You should see if the sum itself is high or low, and then check that against what the user bet, right? And if it matches, then the user wins. If there's no match, the user loses. Then at the end, you should ask the user if they want to play again. Right, so here's the bones of the program, right? This is what you need to have happen. And if you want to let the user play as many times as they want, then all these 4 highlighted lines need to be inside a global loop, probably a while loop in this case, that lets the user just run those lines of code again if they feel like, if they want to play again. So again, once you start writing more sophisticated programs, I would suggest you do this before you start coding. Sort of get a roadmap in your head of where things are going to go, right? So, and when you do that, you can see where like if statements might be relative to where loops might be, okay? Because we see there's an if statement here, right? Because there's an English word if, and that's going to happen inside of a loop. Because we said here, right, all the above code must be inside of a loop. Right, so you can sort of see the structure of your program. It makes writing the code easier. Let me just show you the code. I've already written it to save myself some time here. Whoops. Not there, but here. Okay. So at the very top of this program, I have import random, right? Because if I'm going to roll some dice, I need that random library plugged in. My default response here to this question, do you want to play again? Right, that's the question at the end of the program. My default response is yes up front because we're assuming the user wants to play at least once. Okay, as long as response is yes, which initially it is, right? Initially they want to play, then you get the bet from them. And notice, you can get the bet however you feel like. I decided to give them these instructions, 1 for low and 2 for high, right? So they'll enter a number for their bet, 1 or 2. You could, of course, put not INT here, but STR, and have them just type low or high if you want to. It doesn't matter, right? Anyway, so you roll these 2 dice. You record their sum. Okay, now check this out. If sum is less than or equal to 6, and they bet 1, right? Because recall, 1 was for low, right? If they've done that, if that's what happened, the user wins because their bet matches the sum. Well, there's another way the user could win, right? Or the sum was high and they bet high, right? And notice I have these 2 Boolean expressions here, that one and that one, with parentheses around them. if you take these parentheses off, the computer gets confused as to what's anding and what's oring here, you know? So this is an and statement, right? This is also an and statement. Those are the two win conditions for you. You can do one of those or the other. Okay, so anyway, so if your bet matches the sum, where your bet could be high or bet could be low, then you win. So you'll have it print, the sum is whatever, like tell them what the dice rolled, and then tell them you won. Otherwise, right, if you didn't hit either of the two win conditions, then you will lose. Okay, so this text is running off the screen here, but let me just show you this last line of code. Response string input, do you want to play again? Enter yes if you do. That's all it tells them, right? Okay, so at the end of the program, we will ask them, you want to play again? And if they say yes, well then response, that variable, is still yes. Right? If they type yes right here, therefore when you jump back up to the loop to check the condition here, the response will still be yes, so you'll do it all again. If the user, for this code I've written, right, if the user types anything besides lowercase yes, this loop will terminate and the program is over. So you perhaps might want, I don't know, something like this. While response equals yes, or response equals yes, capital, or response equals capital Y, I don't know, right? You may want to consider all the different ways the user tells you things, but it doesn't really matter right now. Okay, so let's run this and see what it does. Get the window going. Enter 1 for low, 2 for high. I'm feeling lucky on low, so I'll enter a 1. The sum is 7, I lost, okay? Do you want to play again? Enter yes if you do. I do. I would type lowercase yes. And then notice, it just does the same thing over again, right? I'm going to bet low again. I won. Okay, good. So far I'm 1 for 2. I'll play again. I'm feeling lucky on high this time, right? High is due, isn't it? There's been a 7 and a low, so let's see. Man, 7 coming up a lot. Let's see if I can win on high. Anyway, so the program works. So you can have a user play this. If you wanted to make the program more sophisticated, you could have them bet monetary amounts as part of this program, right? So after this line of code here, this like, do you bet high or low? You could ask them, well, how much money do you want to bet on that, right? And based on whether they win or lose, you could give them reward or punishment somewhere else in here. So anyway, this program could be expanded to match more of reality when people used to play this with money. Okay, let me show you two quick more examples here. So this second to last example is, how do you choose at random a given element of a list? So given a list, say list 1, how can you choose a random element of the list? And the answer is, well, just choose a random position inside the list, right? So the list has an item at position 0, and it has an item at position 1, position 2, etc., all the way up to 1 less than the length. Right? So if the length of the list is 10, then the last position is 9, or the last index, if you like that word. So I'll just choose an index or a position at random, starting at position 0, ending at the last element. The randomly chosen element of the list is then the list item, which occurs at that index. So to choose an item of a list at random, you can choose just a position of the list at random. That's what this is doing, right? So I will choose at random between, positions 0 through 30, or however long the length of the list is, and then just record the element of the list at that position. Okay, so if you want to choose an element of a list at random, that's how you can do it. Finally, I just want to think about flipping a coin, and the reason I want to think about that is coins can flip heads or tails, right? And heads or tails is not, at least on its surface, a numeric thing, right? Like the word heads, the word tails, those are strings. So flipping a coin on its face seems like a task between choosing at random, right, between the English string tails and the English string heads, right? It doesn't seem like a numeric thing. But of course, you can make it a random or a numeric thing if you want to. So what I have here, right, I'm thinking of choosing a random number between 1 and 2, right? So choosing either 1 or 2 at random. And 1 I will just think of as being a heads here. and 2 I would just think of as being a tails. Right, so even though heads and tails themselves are English, you can of course encode them as numbers if you feel like, right? So anyway, keep that in mind. If you're trying to choose things at random and those things aren't numeric, like heads or tails, you can oftentimes just make them numeric via an encoding like this. Like, oh, heads or tails aren't numbers, but I'm just going to think of heads as 1, I'll think of tails as 2, and then choose between 1 and 2 at random, right? And then record, like I have to know I've done that, right? But this code here knows that 1 means heads, and otherwise a 2 would mean a tails. Okay, so at the end of this video, you should be able to choose at random numbers in a given range, elements of a list, and you should be somewhat comfortable with incorporating that into tools we already have, such as loops, such as if statements.